Hello teachers and students. Today I'm going to run you through a demonstration kind of connecting the processes of photosynthesis and cellular respiration. As we know, all living organisms require on these two processes and they kind of coexist together. If you can remember the equation for photosynthesis or cellular respiration, where carbon dioxide plus water equals sugar and oxygen gas as a byproduct is the equation for photosynthesis. If we just reverse this arrow, you can see that it is also the opposite, which is cellular respiration. Okay, so I'm going to go through an investigation here in a second, and there's two parts to the investigation. The first part is just setting up the experiment, and this first part will just show you cellular respiration and the fact that humans or organisms or living animals can exhale or secrete carbon dioxide as a waste product. Okay, so I'll go through the equipment here in front. So as you can see, I have some flasks, 2 beakers, aluminum foil. I have Elodia, which is an aquatic plant. There is a straw, and we have a solution called bicarbonate indicator. This is the solution that is used to measure the carbon dioxide gas in the system. And then there is a scale here that is used to determine how much carbon dioxide there is in a solution, and it is dependent on the pH of the solution. So this right now is starting at the very dark solution, which is a pH of 9. And it will change as CO2 is introduced into this solution. Okay, if the CO2 is then removed from the solution, it will then scale back or slide back to this side over here. So it is totally dependent on the amount of carbon dioxide in the solution. Okay, so let me go ahead and get this started. I'll get set up here. So I'm going to pour some of this into this first flask. There we go. And remember, we start at around 9. So you can see where we are starting here. Okay, so around 9 pH. And then I'm going to blow into this with a straw. Okay, and I am releasing CO2 into this solution. Sounds a bit like an aquarium shop. Okay, so now if we compare this to our scale, we are now on the other end of this, somewhere in the pH range of 7.8 to 8, a pH of 7.8. Maybe it is even closer to 7.6. So this might not be the best scale because it doesn't expand all the way to the ends. But it gives you kind of an idea of how this solution can be used to measure the amount of carbon dioxide. So I just blew into this solution, which was over here in this purple range. We're now in the yellow range. This is exactly what is happening to our oceans and aquatic systems with the release of carbon dioxide through burning of fossil fuels and so on. Okay, so the oceans are becoming acidified because you can see if we're here at the purple, it is 7.8 or 8, and then down here we're in the pH range of 7.6. Okay, if this is an ocean, it could be off this scale because the oceans are decreasing in pH. Okay, so now what I will do, if I don't have, I might not have enough of this solution, we'll see. So I'm going to pour equal halves of this. This is part 2, I guess you could say. So part 1 was just setting up the solution, adding the carbon dioxide. So this was me exhaling carbon dioxide through the process of cellular respiration. Okay, I'm now going to add some of this aquatic plant to each of them. And at this point, you might guess or you can predict what the outcome of this will be. So I will put a sprig of this plant into each of these. And this is Elodia, which is just a pond plant. So any pond plant would work. It needs to be an aquatic plant because we are using a liquid. We cannot do this with a land or terrestrial plant. Okay, so I have these here, and I will cover one of them with tin foil to simulate darkness, or a situation where there is no light. Okay, so I'll cover this one completely, and these will just sit. Ideally, I should have a plant light, so I might get a plant light, and I will leave these here and come back and take a measurement every 10 to 15 minutes. So that'll be kind of a time-lapse part of this experiment. And then we'll come to the end and we'll wrap this up and discuss some possibilities of the results. Okay, so roughly 45 minutes has passed, and you can obviously see the difference between these two. Whoops. Here we go. So we have this darker purple one. This was in the light, and we're here probably closer to this color in here. And then on the other end, we're still at the same color of yellow. So this one that was in the light, the plant was going through photosynthesis. It was absorbing the CO2, so we have a color change. This one might actually even get a lighter color of yellow, because in the dark, the plants are not going through photosynthesis, obviously, because there's no light. The other process the plant will be going through is cellular respiration. So plants, even the plant in the light is going through cell respiration, but the cell respiration is at a rate that is lower than photosynthesis. Okay, I hope that helps you understand these two processes and how they connect. And this lab can be easily adapted for different plants, different conditions, different variables, etc. Maybe looking at how temperature affects these two processes here. Okay, thank you very much.